Right, had the unit working for sort of like 4 or 5 hours, and it works fine on DC, and then it started to develop its fault again on AC. Just brought it into the workshop. I thought the chip had gone wrong again. I was trying to work out why the hell the chip would fail again. It's actually turning out that, obviously I didn't get exact readings from the last test I did, but I was getting a DC offset on this when it comes into the RMS converter, quite a strong negative DC offset. But not only that, it was actually really noisy as well. So I've tracked it back and back here, and I've selected various FETs at different points to try and work out where this source is coming from. And it's turned out it looks like it's coming from, I've written it down somewhere, Q303. With any of these other transistors turned on, there's no noise. If I monitor this point here, or on the input of this transistor here, there's no noise. If I turn this transistor on, we get noise. And likewise, if I monitor at this point, I've got noise. But if that transistor's turned off, the noise goes. Any of the other transistors are on, there's no noise. That transistor always gives me noise. So I'm going to look to replace this Q303. I think one of the junctions is failing, and it's generating sort of noise, and the amplifier's trying to keep a DC balance, but because there's noise on the signal, it can't keep the level in check, and therefore it's causing these strange errors on the output, and therefore the AC conversion can't take place, and it just comes up with a calibration fail. So let me see if I can show you on the scope what it's doing. I have just resoldered the joints of the transistor just to see if that's helped at all. It's better actually. I'll zoom you in on the scope. So we're looking for a really clean signal. I'm not putting any signal into the scope at the moment, so you're going to get a little bit of noise, but we don't see any disturbance at all in the scope. And you can see that. It's there all the time. I tried freezing the transistor, it hasn't seemed to make any difference. But all the time that transistor's on, that noise is there. If I turn that transistor off, that transistor now turned off, you see it stops. As soon as I turn it back on again, so in the lower ranges, it's all over the place. So that transistor I think needs to be changed. It's an N-junction FET, I think it's an N-junction. They're opposite to the feed. I think it actually might be a P-junction. I need to check. And I think it's the opposite on a FET with which way the arrow points. But you can clearly see there is disturbance there, and it's still messing around. Initially I thought it was a biasing problem, but that wouldn't explain why it would only do it when that transistor's on. So I'm going to change this transistor, I think, and we'll see if that fault goes away. Well, that high ripple was actually finally tracked down, believe it or not, to the power supply, and I'm sure there are a lot of people out there saying, "Told you so, you should always replace all the electrolytic capacitors." In this case, well, not all of them, but yes, certainly these two here, and these two here were originally I think 330 at 50 volts, and I had a high sort of, it wasn't a low frequency ripple, but it was sort of almost like when the processor was demanding current, or anything on the board was demanding current, the power supply was sagging. Because it's quite a low powered power supply, I think it relies on quite high capacitance to sort of filter that sort of thing out. So I replaced the capacitors with high quality Panasonic capacitors, and the ripples reduced by a massive amount, really noticeable, so that's good. There's a capacitor at the back here, this capacitor here, which was 1000 mic at 50 volts. I measured that, and that had a really low ESR, wasn't leaky, and that supplies the 5 volts. 5 volts is generally used for the sort of like the logic and things like this, and the problem was obviously with the AC board, which mainly relies on the plus or minus 15 volt rail for the op amps and things like that. This is the AC rail here, AC board here. So I popped it back together, and it seems fine. Now, it was a bit odd initially when I first tested it yesterday, and it was working fine. It progressively got worse through the day, and then totally died. And I'm just thinking that maybe it was these capacitors that were failing. I did have it running on the bench for 2 hours this evening before I changed the capacitors, and it was working fine, even though there was a lot of disturbance on the plus or minus 15 volt rails, which I wasn't happy with. And I thought, well, I'll give it a go. Then sort of conscience got the better of me, and I thought, well, no, I think what I'll do is I will replace those capacitors. And this isn't a particularly nice unit to work on, and it's not just this meter itself, it's just that they're coming to this era now where they are sort of built by sort of snapping connections and things, and everything's sort of like held in with sort of like, not snap connectors, but you have to insert plastic dowels and things like that. It's none of your nut and bolt sort of proper hardware technology that I'm used to and I like working with. Don't get me wrong, it's supposed to be a great meter, and hopefully that will prove that when I start using it. But at the moment it's working fine, so let's get the cover back in again. I'm going to need to just leave this running. I might take it into work and just leave it running just to see if it performs properly. But, I can't see why it shouldn't. I seem to have reduced a lot of noise on the supply line. Interestingly enough, that the 15 volts do go through a linear regulator and then are filtered, and then they're fed straight to the AC board through a couple of Zener diodes just to drop the voltage slightly. But there is no decoupling on the, as I might have mentioned this before, no decoupling on the actual AC board, which I was a bit surprised at. But at the moment it seems to be working okay. Let's put it back together and put it through its test, do an auto cal on it and a self-test and things like that, make sure it's okay. Okay, it's connected up to this Ronin voltage calibrator. Select DC volts, and we'll select 10 volt range on this, and we'll select 1 volt output. Turn our filter off. Where is it? No, it's still got mess on. How do we turn that off? Off. Okay, there we go. Got the polarity around the wrong way. Let's put that correct. So, okay, that'll be useful. So it's outputting 1 volt. I've got 1.00011. Not sure how accurate this Ronin is, but it's pretty close. Let's reverse that. Should be the same. Obviously a positive signal. Let's increase that to 5 volts. Looks good as well. And on the just for information, the 34401 is showing 5.009, which is exactly the same figure. So that's looks like that's working nicely. Let's try it on some of the lower ranges. So let's go on to the 100 millivolt range. This should be 50 millivolts, 50.006, floating around there. Exactly what the 34401 is showing. So that looks like that's working correctly as well. So let's try it on the resistance range. So you can also use this calibrator for resistance, if I can remember how to do it. So let's go on the 1K range, and you set the resistance with these pots. So let's set that to, you see the top left hand display here is showing my resistance. So it's 1005 ohms. So the output into ohms should be there, I think. And I press ohms on here. Yeah, 1000.6. Well, 1006 ohms it's showing here, and the Ronin is showing 1005. So take into mind the length of the lead. I've got quite a long lead on this, so that looks pretty damn spot on as well. And we can check our current, and we'll do that by clicking up to the current lead and setting this to, it's only capable of 60 milliamps, but it will actually do a bit more than that, but I think it's rated to 60 milliamps maximum. So let's go, it keeps going to 0. Why is it not going to milliamps? Why is that not changing? Doing something wrong here? I don't know why that one's flashing. Okay. So this should be 5 milliamps. So we go to DC amps. 5 milliamps, as you can see. So that's working nicely. It's working pretty well. So it looks like the meter's working fine. I haven't checked it on 4-wire or anything like that. There's no reason to think it won't work on 4-wire. I haven't tried it on AC current. There are a couple of other things it will do. The frequency does work correctly as well. I've confirmed that. I can do that now by just connecting it up. It's easy enough to do. So go to AC volts again, and Broden Schwartz is putting out 1 kilohertz. So we just go frequency. It should be read our frequency out. 999.999. So yeah, it's working well. It's got lots of useful features in here. You're never going to use half of them, but normal things like it's got the auto cal option, offset compensation, auto zero, where it will basically just always try and, when you disconnect it, it will always try and find the zero. It basically nulls itself out, I think. And they've got various things for external triggering. It has got an option to have an inbuilt scanner, so it can scan multiple channels and feed the voltage into the meter. Like if you're data logging or something, you could use that. That's probably never going to be used. You can store numbers of figures and store them into memory. And it's got basically the normal things that you'd find on a digital scope. Obviously got GPIB or HPIB interface. Yeah, so it works. Fairly straightforward fix once you realise that you always check power supplies first, and as Dave Jones says, thou shalt check power supplies and voltages. Yep, that's true, you will, because I was looking for an op-amp instability, and when it turned out to be power supply instability was just making the op-amps go unstable. So I would have saved myself a lot more time if I'd gone back to the power supply and checked again. And it's unusual for me to change capacitors in components like this, because I tend to think that the capacitors of this age, stored in a cool box, they're going to be fine. Clearly it wasn't the case with this. When I changed the capacitors, I got a big reduction in the ripple on the output of the power supply, and this problem has gone away. So thanks for watching, and I think there might be another Roberts radio to come up. Well, we've seen on the scope, it's just failed calibration again, even though most of the time it works fine. Every now and then it failed calibration. What you're looking now is noise on the input of the amplifier, and that noise is at this capacitor C201, where my thumb is. You can see that noise is there on that capacitor. And I'm starting to wonder if that capacitor's failing. There's also that other resistor dropping to ground. I'm going to ground that capacitor to 0 volts, and if that signal goes away, that's your problem. So let's ground that to 0 volts and just see what that does. So I'm going to ground one end of it. It's more stable. I'll use the other end. Difficult to get a connection in there because the crop clips on there already. Yeah, right, that capacitor's coming out. I think that capacitor's breaking down. It's a 630 volt capacitor. Actually, we'll try some freedom. You see how nuts that is? Let's slow the time base down so you can see a bit better. Put it in roll mode to the bright side a bit so you can see. There's no way that that's right. So let's give it a squirt with the freezer. Did it settle it down? I think it has. Yeah, it seems to have settled it down. It's still moving about all over the place. I will check those other 2 resistors, give those a squirt with the freezer as well. So it's 373 and 374. It's back again now, really noisily. 373 and 374. 373 is here. Just give it a move about. Obviously that's me touching the board. Obviously it's high sensitivity on this end here. Just giving the resistors a move about. Sometimes if these are carbon resistors, just bending them about will actually stabilise everything. Okay, I think I'm going to change that capacitor. So it's a 0.15 at 630 volts. Now I'm not entirely sure how important that is, but let's get it changed so we can get rid of that noise. I found it at last. Oh, and it's definitely passing now. The noise is totally gone. I've tried a number of things. You can see we had lots of noise on this line here. Couldn't work out where it was coming from. I was starting to wonder if it was this chip here feeding it back into the gate of the FET and modulating the FET and making the FET sort of mess about. I actually removed this chip, exactly the same problem. So we isolated the here at this point, same problem. This transistor here, all the time this transistor was on, there was a lot of noise. All the time that transistor was off, it was fine. I've isolated everything I could think of. So I've isolated this section here. I've changed this FET. That made no difference at all. I've disconnected it from this gate of this FET here. No difference at all. So basically the circuit's isolated. I'm still getting this noise, and it's driving around the bloody bend. And I was thinking, well, all the other FETs are turned off, so it's not those. But I thought, well, I've got spare end FETs. This is, bear in mind, this is about 6 hours later. It's a 11:15 now. Took these 3 FETs out and replaced them, and it's fine. The noise has gone away. So even with these FETs turned off, if there's a signal being applied to the source or the drain or whatever this is, I don't know if these have got a source or drain. One of the junctions of the transistor other than the gate, they can still produce noise, and it looks like that's what the problem was. And it's running a self-diagnostic on AC leveling at the moment. It's just clicking away, pass. Now before, what it was doing is going pass, and then it would just say fail. Now what it's supposed to do, if this is the AC roll-off response, and if it goes high, it will say plus, and if it goes low, it will go minus. But it was just saying, occasionally it was just saying fail. The other thing I noticed actually when I was testing it, I couldn't use the low AC range. The AC range had so much noise on it, and it was just causing it to overload all the time, just overrange all the time, even when the front panel is shorted. Let's quit out of this. It's clearly working absolutely fine now. I'm so pleased, because this was really getting my wick after a while. AC volts. And now I can use the lowest range, and you just get the normal noise you'd expect in the background. So, yeah, they're the 4 FETs that I replaced. Funny enough, I checked most of these FETs, some of them out of the circuit, some of them in circuit, and they all passed as fine. This is the op amp I removed this is part of the feedback loop, took that out to make sure that there wasn't getting in from further up the line sort of thing. That capacitor I thought had failed. That hadn't failed. It was just because all the signals being bled back in. All it was a noisy JFET. And funny enough, also can of freezer. The only thing I saw which made me think possibly it was a FET was when I squirted Q, I think it was 304, this transistor here, the biasing changed slightly on the output, and I'm thinking, well, that's a sign of a leaky transistor. So I thought, well, just easy, just to shotgun the whole lot, change all the transistors. Certainly seems to have done the trick. So let's get the thing back together again, and I don't have to take it apart again. Right, let's see if it does a self-cal then. So we run an automatic calibration on the whole system. No, I just did, we'll do the whole system calibration. And this is basically doing ohms, volts, amps, AC volts, AC current, the whole caboodle. And obviously this probably will need calibrating, being that there was an offset on the AC signal all the time from that leaky FET. It takes about 30 seconds to perform. Got to find a space to put this meter now. There we go. No problem. No error message. Oh, have we got an error message? Yeah, we've got an error message. Great. What have we got now? Hardware error. Oh, God. Does it ever end, this thing? Aux error. Enter 256. That's AC level. Not flat again. Okay, so let's just do a diagnostic on the... I don't know why that failed. passing at the flatness point, so this is the test for that. So okay, anyway, it's working as far as I can tell. I've got to find out why it's done that. Okay, you've seen the last video that it's still failing on the AC flatness level after I've changed these FETs. I've just compared the FETs with the FETs I've replaced, and the only difference between the two FETs I can see there is obvious is the junction resistance between the two collectors or sources or drains or whatever these are, the common connection on the FET. Basically it's like an electronic switch, it's as simple as that. A much lower resistance on the FETs I put in than the ones I took out. So what I did was this is where the calibration signal gets fed in through here. This is your trimming capacitor to adjust the flatness level, and it goes to this transistor. So I connected up it to the diagnostics, which you saw yesterday when it was saying pass, and basically that you adjust this capacitor to balance to get the flatness correct. You saw that on the front panel on the previous clip of the video. And this is the only transistor in use at the time. So I thought, well, the only option I've possibly got to get this to work is to replace one of the other transistors and hopefully choose the one that wasn't faulty, and I've no idea which one it is because it's not obvious. They all appear to be the same. So I've removed the transistor I initially put in, the replacement one, and I've replaced it with one of the original ones, hopefully from another point of the circuit, or maybe, hopefully, all I'm interested in is make sure I replace the transistor that's not noisy. So pop that in, and then we'll do another test now. So first of all, I think we'll start with the AutoCal again. So AutoCal, do the whole thing like we did yesterday. Just bear with me. The relay's clicking away. Now this is the low level bit, and I would have thought this would be the most sensitive to capacitance, its series resistance, things like that. I would have thought the next sort of transistors up that pass the higher level aren't so critical, and you could pull that in with sort of like software calibration. I don't think that lower, if this transistor that I've just replaced is wrong, you'll never get it to pass calibration. And that's what we're looking for, no flashing error annunciation, and there isn't. Okay, so it's past that, that's good. Let's just do a full hardware test. This is basically the full hardware test on the machine. Self-test okay. Excellent. So it was that transistor, probably just a mismatch, not allowing the signal to pass, or the degradation in the signal being passed. So that looks fine. The only thing to do is just quickly verify it's actually working. But I think I think we've had enough of this meter. It was a bit of a drag because there was a couple of things. It was, first of all, the shift register was open circuit feeding on the op amps, and of course it was very hard to spot that until we realised that if you connected two connections to the op amps, these points were floating all over the place because there's no connection from this U314. So when I was probing on 1 meter, it all looked okay, apart from when you switched the states, the point wasn't changing, and I was thinking it was the scope. I was thinking it was this op-amp comparator here, but what it actually turned out to be, because the inputs were just floating, as soon as I touched the scope probe on here, it shifted the point. So even though the op-amp was working correctly, I thought it looked like it wasn't, so I replaced the op-amp to no avail. You know, then you start looking for sort of like pull-up resistors the wrong value, and sort of like diodes are leaky. It was none of that. It was basically because this input was open circuit. So we changed it to shift register 4094. That got the control lines back working. So this is basically a sum up really what I've done. Then we tried to track down this bloody noisy loop that we had, and we went all the way around the circuit, isolating sections. We pulled this resistor out here. We did various things. We disconnected this op amp so there was no feedback into the circuit, and we narrowed it down to initially what it looked like the power supply. Previously to that, I'd actually changed the capacitors in the power supply and the main supply that feed all this regulated circuit here, all this little diode regulator here. That improved things very slightly, but it was still very, very noisy. So So after many hours of tracking through and changing capacitors, we changed this capacitor up here, because at one minute point I thought it was that capacitor here, this C301, and it wasn't. So we eventually tracked it down to, well, all the time this transistor was on, it was noisy. We changed that transistor, made no difference at all. It was starting to run out of ideas. And then we pulled all the transistors out, and the noise went away when we replaced them with the aftermarket ones I put in. So that looked like it finally fixed the problem altogether. So we put the feedback circuitry back in, that op amp up there, put that back in, and we put the resistor back in down there, this resistor here, this R311 1K. And it seemed to work fine. Needed to recalibrate the lower level, the low range, which is fine because that's passing through that Q302. But everything else seemed to be absolutely fine, and it's the first time I actually managed to get the low millivolt range to work correctly. But then it failed the self-calibration test and the self-diagnostic test with the flatness error again. So we went through the flatness error check, that appeared to be correct. So the last thing I did, which was this morning, was to replace that transistor here that was the one I'd replaced with an aftermarket Chinese one, and I put back in one of the HP transistors that I cannot cross-reference. Whatever I do, it's a really difficult number to cross-reference. It's not even listed. Put it back with one of the original transistors, and we've got a pass. So it looks like it's fine. I've just got to do a couple of low-level AC level checks to make sure that the after I replace that transistor again, I'm still in calibration. It's easy enough to calibrate this meter. Anyway, thanks for watching, and as I say, more to come.